Let's be real. In the world of software today, it's all about one thing: shipping great code fast. But how do you push out new features every single day or even every hour without breaking everything? The answer is automation. And honestly, one of the most powerful tools for this is GitLab CI/CD. It's not just some add-on, it's a whole system designed to take your code from a single commit all the way into production. It's pretty amazing. All right, let's get into it. So here's what we're going to cover. We'll start with the challenge that every modern dev team is facing. Then we'll see how GitLab offers this really cool integrated solution. After that, we're going to dissect a pipeline, piece by piece. We'll even build our first basic pipeline together, check out some seriously powerful advanced features, and then wrap it all up by talking about how you can automate, secure, and really evolve your whole process. Okay, so let's set the scene. The pressure is on, right? Every team is expected to deliver software faster, make it safer, and more reliable than ever before. This constant tug-of-war between moving fast and not breaking things, that's the fundamental challenge for pretty much any dev team out there. And that really gets to the heart of it, doesn't it? How do you move at the speed of light, innovating and pushing out features, while also making sure your app is solid and dependable? How do you ship quality code faster without that constant fear that you're about to crash production? This is the exact problem that CI/CD was born to solve. And this is exactly where GitLab comes into the picture. It offers a completely integrated solution. So instead of trying to duct tape a bunch of different tools together, GitLab's whole philosophy is to unify the entire DevOps lifecycle into one single platform. Let's break down the two big ideas here. First, you've got continuous integration, or CI. The concept is actually pretty simple. Developers are constantly merging their code into a shared repository, like multiple times a day. And every single time a merge happens, an automated process kicks off that builds the app and runs a ton of tests. The real magic? You catch those tricky integration bugs almost instantly, not weeks down the line when they've turned into an absolute nightmare to track down and fix. And that leads us straight to the other half of the coin, continuous deployment, or CD. So once the CI part passes with flying colors, all the builds and tests are green, the code is then automatically pushed out. It could go to a staging server for review, or hey, even straight into the live production environment. This part is so crucial because it automates the release itself, which takes human error out of the picture and makes your deployments super fast, totally consistent, and way, way less risky. So you might be asking, why GitLab for all this? And honestly, this slide just nails the answer. In a more traditional setup, you'd have your code in one place, maybe use something like Jenkins for CI, and then have this whole mess of plugins just to get them to talk to each other. GitLab's approach is different. It's all in one box. Your source code, your CI/CD pipelines, even your security scans and monitoring, it's all part of the same application. There's no complex external setup you have to worry about. And it really all boils down to their core vision, which is to provide complete DevOps in a single application. It's all about creating this seamless, frictionless workflow where the automation lives right next to your code. This just turbocharges that feedback loop between writing a line of code and actually seeing it running successfully out in the world. So, how does GitLab actually pull this off? To get that, we need to pop the hood and look at the anatomy of a pipeline. What are the actual building blocks that make this whole thing tick? Okay, the best way to think about this is like a factory assembly line. The entire assembly line, from start to finish, that's your pipeline. That line is broken down into logical sections, which we call stages. Like an assembly stage, a painting stage, and a quality check stage. Inside each stage, you have individual jobs, which are the specific tasks being done. Now, the work itself is done by a runner. You can think of the runner as the actual robotic arm on the assembly line doing the work. And finally, you have artifacts. These are just the files or outputs that get passed from one job to the next. So, putting it all together, the workflow looks something like this. First, a developer commits their code. That single action automatically triggers a brand new pipeline. A runner, which is listening for work, picks up the first available job and starts executing the commands. As jobs finish, they might store artifacts, maybe a test report or the compiled application itself. And then, in the final stage, that application gets deployed to its environment. It's a fully automated chain reaction from code to production. Okay, enough theory. That all sounds great, but let's get practical. How do you actually tell GitLab what to do? Well, it all happens inside a single file, and it's written in a really simple language called YAML. Everything, and I mean everything, starts with this one file in the root of your project, test.gitlabci.yaml. Think of this file as the blueprint for your entire automation factory. And the very first thing you're almost always going to define are the stages. This part is so important because the order you list them here, build, then test, then deploy, is the exact sequence they will run in. Nothing in the test stage can even start until every single job in the build stage has finished successfully. Next up, you define the actual work by creating jobs. So here we've created a job called build job. We tell it which stage it belongs to, in this case build, and then under the script section, you just list out the exact shell commands you would have typed into your own terminal. It's really that simple. GitLab's runner just takes these commands and executes them for you. And here we go, a complete though simple pipeline. We've got jobs for building, testing, and deploying. The moment GitLab sees this file in your repository, it knows the entire plan. It's going to run the build job first. If, and only if that succeeds, it'll move on to the test job. And if that passes, it'll finally run your deployment. In just a few lines of text, you've turned a manual, error-prone process into something that's totally repeatable and automated. Now, simple pipelines are fantastic, but let's be honest, real-world projects can get a little messy and complicated. So let's check out a few of the more advanced features that let you build some seriously powerful and efficient pipelines. So what if you need to run your tests against, say, 3 different versions of Node.js? Doing that one after the other would be super slow. This is where a parallel matrix becomes a total game changer. With just this little bit of configuration, GitLab will automatically spin up 3 separate parallel jobs, one for each node version, and run your tests on all of them at the exact same time. This can literally slash your pipeline's runtime. You also get this incredible level of fine-grained control. You can use rules to act like a bouncer for your jobs, deciding if they should run at all, like, for example, only deploying when code is merged to the main branch. You can set a job to when manual, which is like a big pause button, making the pipeline wait for a human to physically click go before it proceeds. And for big projects, you can use include to break your huge config file into smaller, reusable chunks. It's a lifesaver. Okay, let's zoom out for a second and look at the real-world impact of all this. Because this is about more than just running some scripts automatically. It's about weaving security and operations right into the fabric of your development process. And this brings us to one of my favorite topics, DevSecOps. GitLab doesn't treat security like some afterthought you tack on at the end. It builds an entire suite of security scanners directly into the platform. You can automatically run static application security testing, which scans your source code for problems, and dynamic testing, which pokes at your running application for vulnerabilities. You can also scan your dependencies, your containers, and even detect if you accidentally committed a password, all inside the very same pipeline that builds and deploys your code. Now, if you're wondering how this stacks up against a more traditional tool like Jenkins, this table really crystallizes the difference. With Jenkins, you're managing a separate server and hunting for third-party plugins for pretty much everything. With GitLab, it's all-inclusive. The configuration is simpler, the integration with your code is seamless, and critical features like security are just built in from day one, not bolted on later. All right, so as you go off and build your own awesome pipelines, here are a few pro tips to keep in mind. Always focus on keeping them fast and efficient. Use that include keyword to avoid repeating yourself. Please protect your main branch with merge approvals. Store your secrets, like API keys, in secure CI/CD variables, never in your code. And use rules to be smart about not running jobs you don't actually need. So what are the big things to remember here? First, GitLab is a single application for the entire DevOps lifecycle. It just simplifies your whole toolchain. Second, it uses that simple but incredibly powerful YAML format to define your automation. Third, security isn't an option. It's built in, not bolted on. And finally, this thing is built to scale, from your tiny personal project all the way up to massive, complex enterprise deployments. And that brings us to our last thought for the day. Bringing a tool like GitLab CI/CD into your workflow isn't just about making your old process run on its own. It's about fundamentally changing how you build and deliver software, making your team faster, safer, and way more collaborative. So the question I want to leave you with is this: is your process just automation, or is it evolution?